Factor completely. 3t squared minus 2t minus 8. So things get a little bit more complex when you're factoring if you have a leading term coefficient. So if this is not equal to 1, everything gets a little bit more complicated. There's lots of different ways of handling this problem. One is to just use a guess and check method, which is to just know that the result is always going to be a linear times a linear. And a linear, of course, always looks like the form m times x plus b. So a constant times your variable plus another constant. So that means that this would look like, let's say, a times t plus b, and then c times t plus d, where a, b, c, and d are constants that we're looking for. So we're effectively just looking for those constants. So let me erase them, and let's just guess at what those constants would be. Well, the first two constants, two things that multiply together to give me 3, those are pretty easy because 3 and 1 are really the only possibilities. And of course I don't need to write in the 1, it's just understood. So then 8. 8 has a few factors. 8 could be 1 and 8, 2 and 4. It's not divisible by 3, and then when we get to 4, we're back to this factor, so we're done. We don't have to go any further. These are our only possibilities. So that means I could have a few different possibilities. I could have 3t plus 1, t plus 8, or the 8 and the 1 could be reversed, or I could have 2 and 4, or I could have 4 and 2. Our job is to just really figure out what's most likely here. So the thing is, I need the middle term to add up to -2. So my guess is that the numbers are going to be fairly close together. And one thing that's nice is if any of these values is a factor of this number, that's generally not going to be the one you're looking for, because in order for that to be the case, you would have a common factor among the original terms. So the thing I'm going to try first is just 2 and 4. And we'll just see what happens. That's really all you can do here. So 2 times t would give me 2t. 3t times 4 would give me 12t. Oh, that's no good, because that's going to give me, if one of these was negative, I could get a 10t or a negative 10t, or I could get 14t. That's it. I can't get 2. So I need to try another combination. All right, well, let's just reverse them. Let's switch and put a 4 here and a 2 there. So 4 times t would be 4t, not 4, 6, 4t. 2 times 3t would be 6t. Well, now we're on to something, because I could get 4t and 6t to add up to -2t, provided that the 6 is negative. So 4t minus 6t would be -2t, but to get that to happen, I would need this to be a negative. Guess and check, that is the process. Now, we are certain that this works, because now you could factor it out. So 3t times t is 3t squared. 3t times -2t is -6t. 4 times t is 4t, and 4 times -2 is -8. It all adds up to the correct setup. Now, if you're not so in tune with a process like that, another alternative is to use factor by grouping. So effectively, what you do is you look for two numbers. Or let me write this again. 3t squared minus 2t minus 8. You look for two numbers that multiply to the product of -8 and 3, which would be -24. And then you want them to add up to -2. So two numbers that multiply to -24 but add to 2. Well, 24, we could have 1 and 24, that's no good. 2 and 12, that's no good either. But 4 and 6. Okay, so 4 and 6 we could use. And if it happened that the 6 was negative, sort of probably looks familiar here now. Now, the next thing that we do is we decompose this middle term into 4t minus 6t. Not 64, I don't know why I wrote that. Minus 6t. So we've just split up that middle term into these two terms here. So this is still equal to the original quadratic. But now we can do factor by grouping, because the first two terms, if we group those together, and the second two terms, if we group those together, there's common factors among them. So in the first group, there's a common factor of t, which leaves me 3t plus 4. In the second group, there's a common factor of negative 2, which would again leave me 3t plus 4. And there's the key, really, that these two are now matching. So they are technically a common factor of this polynomial, which can be pulled out. When you pull out a common factor, what remains is the leftover. And the leftover would be t minus 2. So generally speaking, when you are factoring something of this form, guess and check is usually faster. But it can take some time if you're not guessing at the right values. So what I do is I generally try guess and check. If one of the two numbers between the leading term coefficient and the constant is a prime value, because that means there's probably not going to be a lot of combinations of numbers to check out. But if they are both non-prime, I'll probably do a method like this because it's a little more time consuming, but it tends to rely less on guessing and checking.